All right, guys, today we're going to be working through problems 5 through 7 on your tests. Before we can begin, we need to review real quick what negative exponents mean. And remember, negative exponents mean that you need to flip whatever the negative exponent is applying to. So you're going to move it or flip it. You guys got really confused on your test about the difference between a negative exponent and a negative coefficient. And you also got confused as to what the negative exponent applies to. The negative exponent only applies to whatever it's touching. So, for example, if I have x to the negative second, then because I have a negative exponent here, it means that I need to flip this x from being in the numerator, because right now it's like x over 1, to being in the denominator. And so our new expression is 1 over x to the positive second. The same way, if I have 1 over x to the negative third, I have a negative exponent in the denominator. I cannot have a negative exponent in my simplified expression, so this is going to switch and it's going to become positive x to the third. I could write it over 1 if I wanted to, but I don't have to. So you have to look at each individual part on its own and think, is there a negative exponent applied to it? If I had something like x, y to the negative third, this negative exponent only applies to what it's touching. If there were parentheses around the x and the y, then the negative 3 would apply to both parts. But because there's not, then it only applies to the y. So my simplified expression here would be x in the numerator, y to the negative third is going to have to move down and become y to the positive third. So that's just a little bit of review of negative exponents before we look at number 5. So let's go to number 5. All right, guys, so here's number 5. It is a difficult problem, but if we tackle it piece by piece, it'll be a little bit easier. So first, we're going to look at the 2 divided by 5. I know that 2 divided by 5 is going to be a fraction, and it's going to be reduced to 1/5. Now, I do not have to write the 1. I could write it, but I don't have to. Okay, I am now done with my fraction. I've simplified that. So now I'm going to look at my x's. I've got 1x on top, and I've got negative 2 on the bottom. I'm actually not at a point where I'm ready to start working with these. Instead, as soon as I see that I've got this negative 2, I know I need to move it up. So over here on my next step, I'm going to have on the numerator the original x that I started with, plus this x to the positive second that I have now brought up. So I have worked with my x's, and now I can look at my y's, and I have y to the 4th over y to the 6th. And in order to simplify that, I notice none of them are a negative, so I am ready to simplify. I have more y's in the denominator, so my answer is going to have y's in the denominator. I know that when I cancel out 4 of them, I'm going to be left with 2, so it's y to the second. Now I can simplify everything in this numerator, and x times x squared is x to the third over 5y to the second. Now a lot of you got that far, but you totally forgot, hey, I've got this negative 2 out here that I have to make sure I remember at the very, very end. So you had to take this whole expression and apply the exponent negative 2. If you notice, you have a power to a power. Actually, you have several powers to power. So you have negative 3 to the negative 2. You're going to have 5 to the negative 2. And you're going to have y to the second to the negative 2. So when I multiply that out, I'm going to have 5. What is 3 times negative 2? Negative 6 over. Then I have 5 to the negative second. And then I have 5 times what is 2 times negative 2 is y to the negative 4th. I notice everything has negative exponents, so I have to flip everything upside down. So my 5 to the second goes to the numerator and becomes 5 to the positive second. And my y to the negative fourth goes to the numerator and becomes y to the positive fourth. And my x to the negative 6 goes to the denominator and becomes x to the positive 6. And the only thing I have to do before I can simplify this expression is I should figure out what 5 to the second power is. 5 to the second power is 25. So I have 25 y to the fourth over x to the 6th. If you take it step by step, splitting up the problem to look at all the numbers first, then look at all of the y's, then look at all of the x's, it makes the problem a lot easier. If you're looking for the key word for problem number 5, the key word is Mason. All right, let's look at number 6. All right, guys, to simplify number 6, you're going to do something very similar as you did to number 5, where you break apart each individual piece. So the first thing I'm going to work with is my coefficients, because that is the easiest thing for me to reduce. What is negative 40 divided by 8? Good, it's negative 5. And then I notice I've got some negative exponents. So before I can start working with my m's and my t's and making sure I'm adding or subtracting appropriately, I need to get rid of my negative exponents. So I have a negative m to the second in the denominator. I need to bring that up to the numerator. So I have the original m to the second power that was already there. And now I also have added to it m to another second power because I have moved this m up. Now, okay, I'm done with my m's at this point. I'm going to look at my t's. For my t's, I have t to the negative third. Well, it has a negative exponent, so it needs to move. So now I've got t to the positive third in the denominator. But I also have t to the negative 7th in the bottom, which means I need to move it up to the numerator. So now I have t to the positive 7th in my numerator. Now that I've got all my negative exponents gone, I can start working with my same bases. So my coefficient's staying the same because it doesn't have anything simplifying it. So I've got negative 5. And then I've got m to the second times m to the second. These have the same base. And we have the same base. We add our exponent, so we get m to the fourth. And then I've got t's here. T to the 7th over t to the 3rd. I have more t's in my numerator, so that means my answer is going to have t's in the numerator. And when I cancel out 3 of them, I will be left with 4 more. So this is my final answer. I had some of you guys doing some very, very silly things, like right here, when you had negative 40 divided by 8, you ended up with negative 48. And I think that's because you were subtracting, but you were forgetting that the subtraction rule only works when you have same base exponents. These right here are just coefficients. They're just numbers. It's like negative 40 divided by 8. All right, so we've worked our way through number 5 and number 6. Your keyword for number 6 is Noah. And now we're going to look at number 7. All right, guys, so for number 7, it's applying one of our last exponent rules, and that is our rule of the power of 0. What we know about the power of 0 is that any number to the power of 0 is going to equal 1. So this whole expression here is to the power of 0. So this whole expression is just the same thing as multiplying by 1. So really all we're doing is looking at this expression to simplify. And this one has a power to a power. So we're going to take this third power and apply it to everything. So I have 3 to the third power, and I have a to the second to the third, which I know I need to multiply my exponent. So this is going to become a to the 6th. To get my final answer, I need to figure out what 3 to the third is. I cannot tell you how many of you guys wrote that 3 to the third power was 9. 3 to the third is like 3 times 3 times 3, which is 9 times 3, which is 27. So my final answer here should have been 27a to the 6th. All right, for your keyword for number 7, it's cardinals. Hopefully you have corrected all of these problems on a separate piece of paper, and now you are ready to do some practice problems. Your practice problems are, the first one is 24b to the 6th, c to the 2nd, divided by 4b to the 5th, c to the 5th, all to the negative 2nd power. Your second practice problem is, actually, I have changed my mind and I'm only going to give you this one for right now. So pause it right now and work out this problem and then come back when you're ready to check. Okay, hopefully you went through and you paused and you worked out the problem and you have a solution. So before we do anything with this exponent on the outside, we have to simplify everything inside the parentheses first. So the first thing we do is 24 divided by 4, which is 6. Good. Done with my coefficients. Then I have b to the 6th over b to the 5th, which I'm going to have more exponents in, more b's in the numerator. And when I cancel out 5 of them, I'm left with 1. So I just have b in the numerator. And then I have c's. When I divide c to the 2nd divided by c to the 5th, I'm going to end up with more c's in my denominator. I'm going to be able to cancel 2 pairs, so I'm left with 3 more in my denominator. I cannot forget, though, that I've got this second power out here. Actually, negative 2nd. So I still have all of this to the negative 2nd. Now I have a power to a power. So I'm going to take this negative 2nd and apply it to everything on the inside. So I have 6 to the negative 2nd, b to the negative 2nd, over c to the negative 6th, because you multiply when you have power to a power. Negative exponents mean to move, so I'm going to move every single thing from the numerator to the denominator or from the denominator to the numerator. So first things first is I move 6 to the 2nd power to the denominator. It becomes 6 to the 2nd, which 6 times 6 is 36. And then I move b to the negative 2nd to the denominator, which becomes b to the positive 2nd. And then I move c to the 6th to the numerator, which becomes c to the positive 6. So that is my simplified expression. All right, hopefully you guys learned a little something. You realized what you did wrong. On our next video, we will work through scientific notation. Thanks, guys.